How can plants heal their own wounds? After a few days away, our potted plant is drooping. A generous helping of water brings it back to life. Is this not amazing? Plants cannot even say they are hurting, so how can they recover on their own? Over millions of years, plants have survived in nature and developed remarkable resilience. One well-known example is the resurrection plant. When water becomes scarce, it curls its leaves inward and folds itself into a ball. Why does it do that? For the same volume, a sphere has the smallest surface area. A smaller surface area reduces water loss through evaporation. It is like the way people curl up to stay warm on a cold day. The resurrection plant can remain in what looks like a dead state for a long time, then unfold its leaves again when the rain returns. Bamboo can produce new shoots even after its stem is cut, as long as its roots remain alive. Dandelions bloom through cracks in concrete, and they stand back up even after being stepped on. So how do plants rebuild their bodies after they are injured? First, the plant forms a mass of cells called a callus. When insects eat the leaves or the stem is cut, the cells around the wound divide rapidly. The new cells gather and begin to fill the wound. Simply put, a callus is the plant's emergency repair team. It is much like repair workers rushing in when a building is damaged. However, this repair team has a special ability. Plant cells can develop into new roots, stems, or leaves depending on the situation. It is like rebuilding Lego bricks into a new shape. That is why a new root and shoot can grow when a branch or stem is cut and planted. So when should cells move? Plant hormones play an important role. The main ones are auxin, cytokinin, and ethylene. First, auxin controls the direction of plant growth. It is also responsible for helping plants grow toward light. Plants do not have eyes, so how do they know where the light is? When light reaches a plant, auxin moves to the side away from the light. The cells on that side grow more, causing the plant to bend toward the light. Auxin acts like a navigation system for plants. When a plant is injured, auxin also helps nearby cells grow and supports recovery. Cytokinin promotes cell division. New cells must form to fill in a wound. Like a factory manager, cytokinin helps oversee the production of new cells. It also plays an important role in the growth of new shoots. What does ethylene do? Plants produce large amounts of ethylene when they are injured or attacked by pathogens. Like an emergency alarm, it signals danger and triggers defense responses. It also helps damaged leaves fall off. By removing the injured part, the plant protects the whole. But is sealing the wound enough? If bacteria or fungi enter through the wound, they can cause even greater damage. So the plant builds a new protective barrier over the wound. The surface of a leaf has a protective layer called the cuticle. It serves a role similar to human skin. When a leaf tears, the plant first forms a new cuticle to seal the wound. It then deposits substances such as lignin and suberin to build a tough cork-like barrier. It is like covering a cracked wall with a temporary patch before reinforcing it with stronger materials. A signaling molecule called jasmonic acid also plays an important role in this process. Viewed in this light, plant wound healing is far from simple. Plants detect damage, send signals, create new cells, and even build a protective barrier. Out of sight, countless tiny repair workers seem to stay busy without rest. Plants cannot move, so instead of running away, they have chosen to recover where they stand. Even a small blade of grass that passes unnoticed holds a remarkable strategy for survival.